Welcome to the Kubernetes Architecture session. Today we are going to go through the Kubernetes, which is one of the most deployed orchestration platform for container management across the globe for highly scalable and available applications such as Google search and a lot of other enterprise applications. So the way we're going to go through this presentation is that first we go through some of the vocabularies of the Kubernetes component, and then we will go through the architectural detail, and then we'll go each of the component of the architecture in detail. So welcome to the session. Before we go into the detailed architecture of the Kubernetes cluster component, let's first go through the some of the key vocabulary. So the first one is the master. The master is the central control plane for the Kubernetes cluster. It manages the cluster resources, schedule pods, and provide a number of other services. The other one is the node. Nodes are the worker machine in the Kubernetes cluster. They run the container that make up your application, right? The next one is the pod. Pods are the smallest deployment unit in the Kubernetes. They are a group of one or more containers that schedule together on the same node. So they are kind of an abstraction of containers. And the other is the container. Containers are the lightweight isolated environment runs on your application code. So all the application, it's like the popular container is the Docker. The next one is the services. Services provide a way of port for communicate with each other. They can also be used to expose port to the outside world for communication point. And the next one is the deployment. Deployments are the way to manage the deployment as set of ports. They can be used to ensure that a specified number of ports are running in all the time and can be used for rolling out a new version of the application without impacting the existing port. So stateful sets are a way to manage the deployment for a set of ports that need maintained state. They can be used to ensure that a specified number of ports are running all the time, and they can be used to roll out a new version of an application without disrupting existing ports. And the config map are the way to store configuration data. They can be used to store things like environment variable, application setting, and other configuration data. And the secrets are the way to store sensitive data. They can be used to store things like password, API keys, and other sensitive data. And the volumes are the way to provide persistent storage for data. They can be used to store things like application data, logs, and other data that need to be persisted across pod restart. Okay, let's go through the Kubernetes overall architecture. So in the picture, we're showing a master controller and also two worker node 1 and worker node 2, with worker node 1 having two pod 1 and pod 2, and node 2 have a pod 1 pod. In a practical deployment, there will be multiple master to have fault tolerance, as well as there will be more nodes to make sure we have the node ports are placed with redundancy in terms of like application high availability point standpoint. So, but this is just the picture what we're showing is just a typical representation. So, we can just go through each of this in function in kind of architectural point of view. From a master controller, we have the etcd, which is the database of the cluster, where we have the configuration of the cluster is stored, and make sure that this is like the etcd is a highly distributed and reliable config store, where it making sure that any failure of the one node, or it doesn't impact actual overall cluster health and application running. And the next component is the API server, which is the main orchestration component of the architecture, all the users as well as the applications APIs are published from the API server, and it also can act as a central component for authentication authorization from the application and user, as well as any of the event subscription is also served by the API server. Now we come to the scheduler. Scheduler is the main the component which will place the pod on the specific node based on the policy and the resources requirement of the pod and the availability of the resources on the node. And we have the control manager, which is tracked overall status of this cluster, as well as if any the status monitoring is done through the control manager. Also, it's making sure that overall the system is running with the what it is configured, and ensure that it is running as expected. And then we have the node. We have multiple components as part of the node. We have the pod, which is an abstraction of the container, multiple container where we are running container, kubelet, and kubeproxy. Each there could be in a node there can be one or two multiple pod based on their resources. The scheduler is placed based on the resources availability and resource required for each of the pod. So if you look at the pod, we have the component like a Docker, kubelet, and as well as a kubeproxy. So Docker is a container where the actual application and any dependency or application is running. So typically pod have multiple containers. That containers serve the common goal. It achieve a common functionality, and they are communicate between the container. They communicate through using the local host, as well as any external communication. That's where the Kubernetes kubeproxy, which is come into play, where it acts as a communication component for the pod, internal as well as for external communication. And then the kubelet is the main component, which is work with the API server, and it's published to API server its availability, and make sure it's whatever is needed from the pod point of view, it work with the API servers to serve the pod functionalities and communication to the API server. So these are the high-level architecture. And then if you look at the networking part, we have the virtual network where we work with within all these nodes and within the cluster to make sure that a reliable and a secure communication goes through using different controllers as well as the services and deployments running in the cluster. Okay, this high kind of overall architecture. Now we'll go through individual component of the architecture. Let's look at the etcd component in the detail. etcd is a key value store that is used to store the configuration data for the Kubernetes cluster. It is a distributed and highly available database that is designed to be resilient to failures, to make sure the cluster, even if failure of etcd on one location, have no impact to the overall cluster running. etcd is used to store information such as the name of the pod, the IP address of the nodes, and the configuration service. Let's look at the API server component of the master controller. API server is one of the key components, which is the orchestration component of the master controller. So it handle multiple responsibilities. API server expose all the API to the users and application, including the user interface of the kubectl command line as well as the API client libraries. The other key responsibility is the state of the Kubernetes cluster. The API server is responsible for managing the state of the Kubernetes cluster. This includes tracking and deletion and update of the Kubernetes resource, as well as the current state of the cluster. The API server is also provide a number of other features such as authentication, authorization, and event streaming. Authentication and authorization allow user to application to access the Kubernetes API only if they have the right appropriate permission. Event streaming allow user and application to subscribe to the event that occurs in the Kubernetes cluster. Let's look at the scheduler component. The scheduler component receives pod object from the API server. These objects describe the pod resource requirement, scheduling constraint, and other properties. Evaluate the pod and the placement. The scheduler evaluates the port placement by considering number of factors including the port resource requirement, the node's available resource, and the port scheduling constraint. Place the pod on the node. The scheduler places the pod on the node that meets the port's resource requirement and scheduling constraints, and notify the API server for the port placement. The scheduler notifies the API server of the port placement. This allows the API server to update the state of the cluster. Let's look at the control manager component. Control manager component runs multiple controllers. The control manager runs a number of controllers, each of which is responsible for a different aspect of the cluster management. For example, there are controllers for managing the pod, nodes, and services. Managing the state of the cluster. The control manager manages the state of the cluster by tracking the creation, deletion, and update of the Kubernetes resources, and ensure that the cluster is healthy. The control manager ensures that the cluster is healthy by monitoring the health of the cluster component, such as pod, nodes, and services. The response to the events. The control manager responds to events that occurs in the cluster, such as the creation of the new pod and the deletion of an existing node. Okay, let's look at the kubeproxy component of the Kubernetes pod. So kubeproxy serves as the communication component of pod on a specified port and forward the request to the approximate port. When the proxy receives a request, it forward request for this approximate port. Provide load balancing. The proxy provide load balancing for incoming request. Provide health check. The proxy provide health check for pod. Configuration option for Kubernetes. So there are certain configuration options available for the proxy. They are the port listen on, IP address that proxy listen on, mode. There are two modes. One is the user space, other one is IP table. Resources, the resources that the proxy allows to use. The health check that the proxy uses to determine if the pod is healthy. Just look at the kubelet component of the pod. The kubelet is the main component which communicates with the API server. First is register with the API server, make sure it presents aware to the API server, and it pull the image for the container image so it can run the containers, and it creating the pod. It creates the pod based on the pod spec which is received from the API server, and it start the container. Kubelet start container in the pod, monitor the container, make sure it monitor the container and restart if they fail, and they stop the container. Kubelet stop container when they are no longer needed and communicate the same to the API server. Let's look at the container element of the pod. The pod can have one or more containers. They work together to serve a common purpose. The resources are shared between this container in a pod, and they are tightly coupled in terms of communication. They can use a local host, and also making sure that they are work together to serve a common purpose. As we discussed earlier, Kubernetes controller have many kind of controllers. So let's go by one. The first is the node controller, which controls and handles the node of the system, node in the system. The service account is enable access control in the system, and the token controller clean up any token for non-existent services. Endpoint control join the services and pod to the node, and replication controller manage the pod of the life cycle. These are the main controller which use in the control manager used by control manager. So let's take a quick look at the Docker versus Kubernetes in terms of feature. So the deployment, first Kubernetes deployed as an application as a combination of pod, deployments, and services. So the Docker, in case, it's always deployment in the form of services. Auto scaling feature. So Docker doesn't support auto scaling, but the Kubernetes support it's auto scaling and scale up and scale down. And the health check for two of kind of liveness and readiness is available from Kubernetes, but from a Docker, I think there's only services limited to services. The setup, Kubernetes is hard to set up. It's a complex to set up and configure, but it is it's once it's set up, it's very highly scalable and performable in the for a large application. And Docker is easy to set up, installation, and easy. It's relatively set up for a small application. Tolerance ratio. So high fault, Kubernetes work for very high fault tolerant. I can run in hundreds and thousands of containers, and Docker is low fault tolerant and it's run for small application. Thanks for attending the Kubernetes architectural session today. So I listed here two more YouTube sessions related to Docker and Kubernetes. If you are interested, so please subscribe to the channel, and thanks again for attending the session today.